I am Lakshmirata from ECEC section, second year. My roll number is 24BQ1A04H5. My topic is complements. In digital systems, complements are used to perform logical operations like to represent signed numbers, to perform both addition and subtraction operations by using ladder circuit. Complements are classified into two types for each base R systems. Base R means example 1, 2, decimal numbers, octal numbers, hexadecimals, etc. Radix complements R's complement and diminished complement R minus 1's complement. Diminished complement. The R minus 1's complement of a number of capital N with number of digits small n is obtained by R power n minus capital N minus 1. For decimal numbers, R is equals to 10 and R minus 1 is equals to 9. So the 9's complement of n is 10 power n minus 1 minus capital N. For example, the 9's complement of 5 lakh 5 546,700 is R equals to 10 and number of digits of capital N is 6. Therefore, R power n is equals to 10 power 6. R, R power n minus 1 is equals to 99999 as we subtracted from the 10 power 6. R minus 1 is R minus 1 minus n is equals to 454532 as we follow the subtraction operation. For primary numbers, R is equals to 2 and R minus 1 is equals to 1. So the ones complement of n is given by follow process. The ones complement of 101101 is R is equals to 2 and n is equals to 6 for capital N value. By following the subtraction process, we get R power n minus 1 minus n that is equals to 0, 1, 0010. For R minus 1's complement of a number can be obtained by subtracting each digit possible in the radix R minus 1. The R's complement of a binary number is obtained by reversal of each bit. It means 1 is reversed by 0 and 0 is reversed by 1. Radix complement. It means R's complement. The R's complement of an n-digit number, capital N, in base R is defined as R power n minus capital N. For capital N not is equals to 0 and as 0 for n is equals to 0. Comparing with the R minus 1's complement, we note that the R's complement is obtained by adding 1 to the R minus 1's complement. Since R power n minus n is equals to R power n minus 1 minus capital N plus 1, it gives the R's complement. We can obtain this by using following expression. Here we took tens complement of the given digit capital N. For decimal number base radix R is equals to 10. The number of digits of the given number is 6. By subtracting the R power n minus capital N, we get 987602. For similarly for 2's complement also, for given capital N digit 101101, the base radix R is equals to 2 and number of digits is equals to 6. R power n minus 1 we get 0, 1, 00. The R's complement of the number is obtained by subtracting first non-zero bit with R and remaining all R by R minus 1. Signed number representation. Positive integers including 0 can be represented as unsigned numbers. To represent negative integers, we need a notation for negative values. It is customary to represent the sign with a bit placed in maximum side bit. It means MSB. The convention is to make the sign bit 0 for positive and to make sign bit 1 for negative. This representation of sign numbers is referred to as the sign magnitude convention. Sign numbers are represented in three types: sign magnitude representation, sign 1 complement, sign 2 2's complement. Sign magnitude representation. In sign magnitude representation, the MSB is signed and remaining all bits are magnitude. There are another representation of sign numbers referred to as the sign R's complement system and sign R minus 1's complement system. Sign 1's complement representation. The negative numbers are represented by taking 1's complement of positive number, including the sign bit. Sign 2's complement representation. The negative numbers are represented by taking 2's complement of the positive number, including the sign bit. The 4-bit sign representation in all three possible ways are listed below. This is how we represent sign magnitude form, sign 1's complement form, sign 2's complement form of decimal numbers. For plus, we use 0 at MSB, and for minus, we use 1 for minus 1, we use 1 at MSB. These are the representation for 7, 0, 11, 0, 1, 1, 1. It is same for sign magnitude form, sign 1's complement form and sign 2's complement form up to plus 0. From minus 0, the values are changed for three complement forms. For minus 1, it is represented as 1, 0, 0, 1 in sign magnitude form, and sign 1's complement means complement of plus 1, it means 1, 1, 1, 0. And in 2's complement, minus 1 is represented as 2's complement of plus 1, 0001. It is 4 ones. This is how we represent it. In practical, while designing digital systems to represent sign numbers, use sign 2's complement form because of effective of combinations. The possible sign numbers range with n bits is sign magnitude and sign 1's complement representation using R 2 power n minus 1 minus 1 to minus of 2 power n minus 1 minus 1, where in sign 2's complement representation 2 power n minus 1 minus 1 to minus of 2 power n minus 1. Subtraction using complements. Using 2's complements. As we know, subtraction is done as a minus b. It is represented as a plus b of minus b. Step 1 is to perform 2's complement of the subtractant minus b. As we get the 2's complement, we should add the subtractant to a. It means add a plus b of minus b. If in summation or addition operation, if we get n carry, discard it. Remaining is equals to a minus b. If MSB is 0, resultant is correct answer. If MSB equals to 1, perform 2's complement of resultant and place a negative sign in front of it. Using 1's complement, perform 1's complement of the subtractant, and then we get the complement. The obtained complement is added to A. If we get n carry, discard it and add 1 plus 1 to the resultant end around carry. If MSB is equals to 0, result is correct answer. If MSB is equals to 1, perform 1's complement of resultant and add negative sign in the MSB. Given the two binary numbers, x is equals to 1 0 1 0 1 0 0 and y is equals to 1 4 zeros 1 1. Perform subtraction operation x minus 1. To perform subtraction operation, we get 2's complement of this xy, and sum is equals to 1 0 0 1 0 0 1. Discard the end carry, then we get 0 0 1 0 0 0 1. This is how we perform subtraction operations for complements. Thank you.